75% of Massachusetts employers don't think that people they hire ready for the job. The growth in STEM bachelors exists mainly due to students with foreign origin. Why don't students go into STEM education? Attracting students into STEM education without asking this question is like dating, without asking why after the first date I never get this girl, why they never go back. What do students try to avoid by not going into STEM education? Science. Why don't students go into STEM education? They don't want to do science. Why don't students want to do science? Because they're afraid to fail. This definition is sufficient to teach science. The key word, data, pattern, prediction. This problem is an example of that specific way of thinking, scientific way of thinking. Why learning science is hard? Because teachers don't use scientific way of thinking when they teach it. That's what makes it hard. All science subjects, first of all, should be used to teach a scientific way of thinking. If we teach science as a collection of facts, as a basket of disconnected information, that's what makes it hard, because there is no logic. Among all school subjects, physics is the best suited for the development of the scientific way of thinking. Because of that, among all school subjects, physics is the best suited for attracting students into STEM education. For hundreds of years, there wasn't physics and chemistry divided. It has been a science, and the same person was a chemist and a physicist, and about only 150 years ago, they started developing independently. Chemistry, physics, the science curriculum represents that previous stage of science development. If we agree that the essence of science education is scientific way of thinking, in that case, physics is the best for developing that ability. Properly taught means using scientific way of thinking. I believe all pathways to STEM education should go through early physics. It doesn't have to be high-level physics, robotics. It's more like a hands-on activity than a scientific inquiry. High level of robotics, it's basically almost engineering. It already requires knowledge of physics. When students start learning physics, they deal with objects they're already familiar with, rocks, cars. If you go to chemistry textbooks, they actually start from physics. They start from density, mass, energy, or atoms and molecules. Well, density, mass, and energy is already physics. Atoms and molecules, first of all, abstract objects. You cannot see them and touch. But if you try to imagine those, you would have to imagine small balls interacting, which also is physics. Computational thinking. First of all, it is a thinking, plus some coding. That part requires advanced logical abilities. If you can't think logically and you know a lot of codes, it doesn't help you. If we look at physics and computational thinking, they share that part which is thinking, but in physics, thinking is being developed, propelled. In computational thinking, thinking is being used. So it has to be developed first. Where? Of course in physics. It's a common myth that you can't do physics without doing heavy mathematics. It's based on my experience that when students hear again and again, physics is hard, you have to do a lot of math, it's only for special ones. That deflects them from going into physics and into science. On the contrary, learning physics helps to get better at mathematics. Many students hate doing word problems, but if you want to solve a word problem, you just have to apply exactly the same scientific way of reasoning. If you get good at that, you get better at mathematics. Physics is uniquely positioned as a bridge between the abstract world of mathematics and the world of real-life phenomena. And again, based on my long-time experience, everybody who knows multiplication table and capable of solving quadratic equation can succeed in physics. It's too late to start it in 11th grade or even in 9th grade. Even if we just stretch the same material over a longer period of time, that would decrease the barrier of raising knowledge. If they have to learn physics in 2 years with this very large amount of information, that also scares them away. But the most important reason for starting learning physics early is the brain development. Because as we know now, brain basically develops like a regular muscle. It requires many and different exercises. So, let's say in gym class, students for 12 years have been doing all the squats. In that case, they wouldn't be able to do pull-ups or push-ups. Same with developing the mind. If for 12 years they have to memorize facts, and that's it, the brain just gets rigid. And it's too late. It's much harder at the later point in time to start teaching or learning reasoning. This is the summary. I just want to ask you one last question. All right. They're afraid of going into this because the way they taught doesn't resonate with the nature of the subject. In order to change the way we teach, we should start from the subject for which this way of thinking is internal, and that is physics. All other subjects also require reasoning and logic. But in physics, this way of thinking is just the most transparent. That's why I suggest physics as a door. If you get confident here, now you can do anything you like. When I have time, I always try to go over a solution of a standard physical problem. There is a solution, and there is a way of reasoning. How did I come up with that solution? That way of reasoning usually is hidden. You can't find it in many textbooks. You can't find it, well, anywhere, right here. So this is what I try to demonstrate at least once or twice. Usually I list those steps, objects. What objects? We talk about it. What do we know about it? What properties? We talk about it. It requires a lot of time, but if I do it once or twice at least, I tell to myself, all right, I did what I could. I think that students love clarity. Students love when they understand what's happening. That's why I try to distill that definition of science to very simple, clear, practical steps. In physics, we cannot ever solve any actual problems. We can only solve a model, a simplification. I use a physical way of thinking. There is a model which describes the essence of a scientific thinking. It doesn't describe everything, but it's sufficient to start. Talk to students. This is science. Let's do this. You feel confident? We can move on. I know that to start doing science, we need to know the names for some important things. We have to be able to talk about those things, and we have to be able to describe the properties of those things and what's happening. If you can't describe it in words, that's already the wall. You can't move ahead. So you have to start from verbal description. Then you gotta start from relating things. A stable, regular relationship. Switch is on, bulb is on. Switch is off, bulb is off. That's a law of nature on this scale, on this level. But starting from this level, we can project it to a higher levels of scientific thinking. Transition might start happening first locally in one school or one school district as a proof of a concept. I always have several problems which I offer to students to solve in exactly the same way we've solved the problem about bulb. After that, a teacher should reflect on the way of thinking through the process of the solution. I could just give away the answer. That would take 2 minutes. Giving away a solution. And students love that. But after that, can they solve a similar problem? Doubt that. The exactly same problem, maybe. But even with a slight alternation, they already get lost. When we solved this problem, did you play with any switches? Did you touch the bulb? No. Where was it happening? We had to imagine everything. So it's not mathematics, it's not even the logic. The most important, the fundamental skill is imagination. Here we go down to kindergarten. That's why reading early is important and role playing is important. People who grew up on computer games and TV shows, they don't have imagination developed. And they can't go into science afterwards. Because imagination is that mechanical internal tool. Those wheels